Hi everyone, today let's solve the problem number 167, 2 sum 2. We have already solved the 2 sum 1. Basically, it's the first problem in the Leetcode, right? So we have solved that one multiple times. That's fine. So let's solve the problem number 167, 2 sum 2. Input array is sorted. So here we have the basically by seeing the question name itself, you would have already guessed that input array is sorted, right? So um, let's see what the question states. Then let's see the further things, right? So what the question states here, we are given an one index sorted array numbers here. So this is one indexed, not the zero. The index starts from one. When they are saying this is one indexed, so the index starts from one, not zero. So this will be 2 3 4 accordingly with the example. So we have from 1 to 4, the elements start from basically index 1. So we are given an one indexed array numbers. We need to find the two indices such that numbers of index 1 plus numbers of index 2 will be equal to target. So there will be two numbers, so which will lead or which will yield to the target, which will basically yield to the target. So we have to return them as index 1 comma index 2, where index 1 is less than index 2. So here we have what we need to do, we have two indices such that numbers of index 1 and numbers of index 2 will be equivalent to the target value, and we have to return them as index 1 comma index 2, right? So we need to return in the array. So this will be index 1 and index 2, which will lead to the target. We have to return in this way, and they have given one more condition: index 1 will be always less than index 2. So this one is very important, and we cannot use the same element twice. So same element, we cannot use the same element twice within the array, right? So that is one thing, and we must only use the constant extra space. So we have to use we have to use only constant extra space. Exactly one solution always exists. They say exactly one solution always exists. So just remember this one. Exactly one solution always exists. So this is the important point they have made, right? So I hope this part is completely clear, right? So I hope the question part is completely clear. Let's come to the example. Let's discuss example first, right? So here what I want to say here is, so see here we have the numbers 2 7 11, this thing. So index 1 and index 2 will yield us to the target in target value, nothing but 9. Here 2 plus 7 will be 9. 9 is equivalent to 9. So this is fine. This is fine. I hope this part is completely clear, right? So we have to return this one, index 1 as well as the index 2 within the array. So this is fine. That's what they have given in the that's what they have given as output. Just give me a second. Yeah, that's what they have given in the output. So here let's come to the second example. Numbers we have 2 3 4 and target we have 6. So here uh, 2 plus 4 will yield us to the target 6. So we have to go with 1 and 3. So we need to return 1 and 3 as output. So this is fine. Let's come to the final example. Here we have minus 1 0 and target is minus 1 here. So we have to go with 1 comma 2. Minus 1 plus 0 will yield us to the target minus 1 itself, right? So we can go with this one, minus 1. So I hope the question part is completely clear, right? So they have given us wonderful examples just for the sake of understanding. So now we know the question. We are completely familiar with the question. So let's do one thing. Let's discuss the approach followed by the complexities, and then let's write the code. So here let's come to the first part, approach. So as I've said, we will be going with a two-pointer approach. Just keep this in mind. We'll be going with a two-pointer approach. This problem is actually designed to be solved with the two pointers. So it's very easy to solve with the two pointers basically, right? So example, we are considering the first example so that it will be easier for us to understand. So this one, basically the target is 9. So adding up 1 and 2, index the element present at the index 1 and 2 uh, has to yield to the target value, nothing but 9. So first step, what we'll do, we'll start with the two pointers, left equals 0 and right equals 3. When we are starting with the two pointers, the left this one, so just give me a second here. The left always, the left pointer and the right pointer we are considering. Left points to the first index and the right points to the last index that is present in the array, right? So in this case, left equals 0, right equals 3, because this is index 0 we are starting with. So this is index 1 based index they have mentioned in the question, right? So 1 based index they have mentioned in the question. right? So just keep this in mind. We initially what we'll do, we'll initialize the left to 0. This is 0 based indexing. So right equals 3 here, 0, 1, 2 and 3, right? So you would have already guessed that we will be adding plus 1, as this is 1 based. So 1 based indexing they have given in the question, right? So if you have already guessed, that is correct. We will be adding plus 1 at the end. This is fine. So the next step here, after the step 1, what we'll do in the step 2, so the numbers of left plus numbers of right. So this we will check. 2 plus 15 will check 17. This will not eat to the target 9, right? 17 is greater than 9. So we will decrement the right. So we'll keep the left as it is, we'll decrement the right. When we decrement to the right, we will move to the second index here. Second index, 0 based index I'm considering. Second index, nothing but the value 11 here. We will consider 11. Now we will do 2 plus 11. That will lead to 13. So first we did this one, we got 17. This time we got 2 plus 11 equals 13, which is again greater than 9. So we will decrement the right. Now we will go to the first index and we have the value 7. 7, right? So this time 2 plus 7 equals 9, right? 2 plus 7 equals quite obviously 9. So the target value is also 9. 9 equals 9. When we compare, 9 equals 9. So we have found the pair. We have found the pair. So we will stop here and we will return the indices left plus 1 and right plus 1. So this is important, right? So again, I want to say the same thing. While explaining the question, I have said that this is one based indexing. They have mentioned this is one based indexing, and we have considered from 0 to 3 indexing, right? So here, as we are writing the code, because it is 0 indexed, we have to add 1 at the end. So this will be pointers for the left and right pointers. This will be left plus 1 and right plus 1 at the end. So here this will be, instead of 0 comma 1, the output will be 1 comma 2, as it is one based indexing. So that they have mentioned in the question. So now we got 1 comma 2 as output, which is equivalent to the output that they have mentioned in the example 1. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case. Right now, as we are completely familiar with the approach, just give me a second. Now, as we are completely familiar with the approach, let's do one thing. Let's discuss the complexities. Let's discuss the complexities very quickly. So what would be the time complexity here? The time complexity would be quite obviously big of n, for the code that we'll be writing in the future. Why it will be big of n? Because we have to scan the array once with the 2 pointers, right? We have to scan the entire array once with the 2 pointers. So quite obviously, this one, what do we call? The time complexity would be big of n. And what would be the space complexity here? The space complexity would be big of 1, because there is no need of extra space used. We'll just be making use of the 2 pointers, left and right, right? Left and right pointers. So the time complexity would be quite obviously big of n, and the space complexity would be big of 1. This is the space complexity and this is the time complexity. Time complexity would be big of n and the space complexity would be big of 1 for the code that we'll be writing in the future. Right. I hope the complexities part is completely clear. Now, as we are completely familiar with the approach as well as the this one, what do you call, complexities and the approach? Now, let's start writing the code. Right. So the first step is, let's initialize the 2 pointers that we use. So here, left equals 0 to the first index, and also in right equals last index, right? So we have to initialize this one to the last index, nothing but numbers dot length, numbers array we have, right? Length of the numbers minus 1, nothing but the last index, hyphen 1 or minus 1. So this is fine. So here, this one, uh, let's go with the while loop, and as we are making use of the 2 pointers here, the left has to be always less than right, until left is less than right. So here first step is, we want the sum of current pair. For that one, we'll be going with this formula, int sum equals numbers of left plus numbers of right. So this is the step that will be, yeah, we are just finding the sum of the current pair. After finding the sum of current pair, we need the result in one indexed, right? The result has to be one indexed, not the 0 indexed. For that one, let's write the simple if condition here. If sum equals target, then accordingly with the this one, accordingly with the approach that we discussed, we can write in this way: return new int. Here in this case, what we will do, new int. So this will be left plus 1 along with the right plus 1. We are just doing with plus 1. We are playing with plus 1 because we need the result 1 index, not the not in the 0 index, right? So this is fine. So else if, let's write one more condition, means we have to increase the sum by moving the left pointer forward, right? So sum, if sum is less than target, I'm speaking of, right? So I have to write this condition, right? So else if sum is less than target, then we need to move the left pointer ahead. So this is fine. I hope this point is completely clear, right? Else uh, we need to decrease the sum by moving the right pointer backward, right? If sum is greater than target. So that we saw, that itself we saw in the approach, right? So sum was greater than target every time for this one. Sum was greater than target for every time when we considered 15 and 11. So as it was greater than target, what we did, we decremented the right. Means we went from 15, then we checked for 11, then we checked for 7. 7 plus 2 matched with the target value. So we stopped there, right? So in this case, else what we need to do, we need to decrement the right. So this is fine. This part, I hope this part is completely clear. So the last part here is we have to return the dummy. We have to return the dummy. Means problem quite obviously guarantees the solution. At least one way, one solution is there. At least one solution is there. They have clearly mentioned in the question. So we need to, let's return the dummy. So I'll just go with return new. So here this will be int of what shall we do? Minus 1 comma minus 1. So this is fine. I hope this part is completely clear, right? So let me format the code once and let me hit the run button. I hope this works, man. Let's see. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases. Yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct. Whatever the code that we have written works absolutely correct. I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.